Very good morning to my fellow panels, and I am Annabel and I will present my project, which is the development of biogas IoT smart stove using kitchen waste.
You must be wondering, do you know that about 930 tons of food is being thrown away every day, which is equivalent to throwing away 93,000 kg bags of rice per day, which can be fed to millions of people. It is considered a very huge loss that the food waste did not use as a benefit. So why kitchen waste? So kitchen waste is eco-friendly. When food waste is used as a fertilizer and produce biogas, this may reduce the air and land pollution and also reduce the greenhouse effect. Next is the kitchen waste able to produce methane gas by anaerobic digestion besides using animal dung. Lastly, it is very economical since it can be collected at any restaurant or even your own kitchen to use and produce the biogas and also the fertilizer. Alright, the next slide shows the pie chart in 2015, showing that the highest fire accident happen is cooking, and this may cause a lot of loss, not just properties, but also lives. So the solution to this problem is to develop biogas IoT smart stove using kitchen waste. For the consumer, it saves money, which they can produce their own cooking gas and also fertilizer. Then next is they can get more work opportunity, such as agriculture field or business. And lastly is the safety with the monitoring IoT system in the kitchen. For the producer, this will gain more money, and also this will motivate them to enhance the project by adding more futuristic, and this also will grow faster by having great review and great price. Okay, before proceeding into the problem statement, I did a market research to 113 respondents. So based on the finding, I can see that most of the respondents is M40 and B40. Next, most of them have gardening area and also Wi-Fi at home, but as we can see here, there are still some community which using firewood as their cooking source, but mostly gas stove has been used, but most of them do not have any safety feature in the kitchen. Alright, so now I will present the problem statement. So most of the households in Malaysia using liquefied natural gas as the cooking gas, which is not renewable and we don't know when it's going to use up. Next is most of the kitchen do not have any monitoring system because sometimes human can be so careless by leaving the stove on. Lastly is not being able to turn off the stove if they are away from home, which can lead to fire accident. Okay, next slide is the objective. So the objective for this project is to develop a biodigester with filter for better quality of cooking gas. Next is to develop a prototype of automatic stove knob to turn the fire off with the use of IoT. Lastly is to analyze the effectiveness of the sensor for detection and control feedback to the stove knob. Alright, for the scope of the project, only food waste is used for the biogas production, and then next is we are focusing on for the biogas production with using the different type of food waste such as fruits, chicken, and also veggie. And the third one is Arduino Uno as the microcontroller that would act as the brain or command center for all the operating in the system. Alright, for the fourth scope, which is the flame sensor can detect flames at 60-degree viewing angle of 0.3 meter to 1 meter. Then the fifth scope is passive infrared sensor is adjust up to 7 meter, and the delay between detection can be set between 5 seconds to 5 minutes. And then for the sixth scope, which is the gas sensor detect gas in the range of 300 ppm to 5000 ppm. So for the Wi-Fi module, Node MCU will be used as the Wi-Fi module to control the servo motor. And lastly is this project provides stove monitoring to the user. Okay, the next slide shows the target market. So for the total addressable market, we are targeting the B40 and M40, which consisting of 2.7 million for both urban and at rural area to this project. Alright, this slide shows the overall process of the flow. So it began when the food waste and water going inside the biodigester, and by anaerobic digestion it will produce fertilizer and biogas, and with the raw biogas it will flow into the filter system, then compressed into the LPG cylinder. After that, it ready to be used and installed to the IoT smart stove that provide monitoring systems such as flame sensor, PIR motion sensor, and MQ4 methane gas sensor. So when either fire sensor that detect the fire in the range of 0.3 to 1 meter, or the gas sensor detect in the range of 500 ppm above, this will link to the Wi-Fi module to send notification when no motion detected in the range less than 7 meter. So user can use the Blink app to turn off the stove wirelessly. Okay, so as we can see this slide, the development of biogas IoT Smart Stove is separated into two parts, which is the biodigester part and also the IoT Smart Stove. From here, biodigester is having three parts, which is the body of biodigester, filtering system, and the biogas storage. Okay, then for the IoT Smart Stove, it's separated into two parts, which is the hardware that using Arduino Uno as a microcontroller and Wi-Fi module, Node MCU as the Wi-Fi module that controls the servo motor, then receives signal from the three sensor, which is PIR sensor, flame sensor, and MQ4 methane gas sensor. Okay, for the software, Fusion 360 is used to do the 3D drawing of the biodigester, and then Proteus for project circuit simulation. And for the computer coding, Arduino software IDE is used. And lastly, for the wireless control stove knob, we'll be using the Blinks app to control. Alright, this is the component for the IoT Smart Stove. So we are using Arduino Uno as the brain for the whole operation, which controls the sensor and the output. And then Node MCU is used for the Wi-Fi module that controls the servo motor and also send notification to the user phone. Alright, next is the flame sensor. So flame sensor is used to sense the fire and also detect the fire in the range of 0.3 meter to 1 meter. And I also use a PIR sensor to detect the motion up to 7 meter. Alright, lastly, I'll be using 180-degree servo motor which is act as the output and also used to control the position of the stove knob. So this will help to turn off the stove. So the next slide shows the material used for the biodigester. So the first one is the body of the biodigester will be used the galvanized steel, which is good in tensile strength and is for rolling by machine, and also it retains the heat absorbed by the digester tank. And the second is the 6 flat blade manual stirrer. So this stirrer will increase the production of biogas and also to mix the food waste and also with the water equally. So in this slide are the materials for the filter system. So we'll be using steel wool, which remove hydrogen sulfide from the raw biogas, and also water is used to remove the carbon dioxide. Okay, lastly, for the last component used is the silica gel, that it will remove the moisture from the raw biogas.
Okay, this is the initial result of the project, which show the functionality of each sensor. So when you see here is all show 0, the initial. So when the gas sensor is triggered, a green LED will light up. And you can see here in the simulation, it shows 1. That means there's presence of the smoke. Okay, so next is the flame sensor. If flame sensor is triggered, it will turn on the light, red LED light, and show flame here is 1. Okay, next is the motion sensor. When it is triggered, it shows the yellow color LED light up, and it will also show here that green motion is 1. And that's all for the sensor.
Okay, this slide show my progress, which I have done. Milestone 1 and some of milestone 2. So milestone 1 consists of literature review, introduction and methodology, and milestone 2 consists of all the design, hardware and software. So I have done the software part, which is constructing the circuit in Proteus software. In conclusion, not only this project helps the community, but it also helps the economy to grow, as well as taking care of the ecosystem. And that's all from me. Thank you.